Once upon a time, there was a high school called Mission San Jose where students were studying hard, failing badly, and generally getting really stressed out. One year, several of those students were working on their biology project when...
Whoa. Hold up. Who do you think you're targeting?
Hey, I'm trying to tell a story here.
To whom? 5-year-old kids? This ain't a children's video, yo. That's boring. What we need here is AP work. You hear me? AP work. Now get to it.
Yeah, I don't want to be made out to be some stupid CP kid. I want good, honest work, and I want those points. I need them. Bad.
Alright. So, they've already popped up, so I might as well introduce them. To the right is Bilbo Haggins. And to the left is Ash Ketchup. And now for the rest of the group. Here's Starfish. And here's Khiem. And finally, there's me, the narrator. Now, let's begin. For our project, we were supposed to go outside and take a look at how nature works. How, you ask? Well, we counted stuff. Literally. Birds, ants, bugs, a tree, dandelions, daisies, grass even. You name it, we counted it, or at least we tried.
Oi. Aren't you being a little too butthurt here? Come on, we gotta make this fun.
Yeah, I agree.
Me 3.
Me 4.
And you guys, get a personality, won't you?
Not until the narrator here gives us one.
You hear that, narrator? Give him some depth.
Fine, geez. You know that's harder than it sounds, right?
Yeah, whatever. We can live without emotions for a bit.
Dude, I'm bored already. Can we get back to our project?
Yes, please.
Okay, so we counted stuff. We recorded it in very poorly made journals. Anyone want to share?
Oh, pick me.
Okay, go ahead.
Alright, here's the data. 3-10-0-1. So what do we do with this?
Yeah, what does it mean?
Narrator, some help here?
Hey, even I don't know everything.
Yay, we're already stuck. This is great.
You know, maybe I can do something if, the data was presented better?
Oh, you mean like this?
Whoa, where'd you get that?
I don't know, I just found it here lying on the ground.
Now that's better, but I think someone else here wants to have a go. Ash Ketchup, you want to try explaining?
Well...
Come on, just try. We're out of options here.
Okay, I'll give it a shot. I think this graph here shows the number of organisms over the days that we observed our plot of land. As you can see, the number of some organisms fluctuated a lot, while the number of others barely changed.
And so, with this graph, what can we tell about the effects of our plot of land, hereby referred to as the POL, on these organisms?
I think there's a term for this. Oh, I know, abiotic factors.
Yes! What abiotic factors are affecting these puny little creatures?
I know.
You don't have to shout, just tell us already.
Well, there are a lot of abiotic factors present. There's, weather?
Right, but there are better terms for that.
Let's see. A little hell.
Temperature, water, sunlight, wind, rocks, and soil.
Wow, good job. I feel smarter already. So, anyone care to tell me how they actually affect the organisms? Yes, let's listen quietly to those crickets. Oh, and I'll get myself an ice cream cone while I am at it. Oh, come on! Will someone speak up already?
Okay, calm down. So let's see. Temperature. Well, organisms can only live within a certain temperature range, so each organism has its own range of acceptable temperatures. For example, polar bears wouldn't be able to live here, but our daisies and birds and ants and bugs and that one tree and dandelions and grass all can and do live here.
That was terribly informative.
Oh, and I know about water. Like temperature, there's a certain amount that each organism needs, and if those needs are not met, then they die a horrible death. Like if we were to get lost in the desert and can't find any water, we dry up and mummify or something.
I am so mind blown right now.
So it's my turn now, huh? Sunlight. Oh, boo-hoo! It's the same thing. There's a good range to be in, and one step outside it, and you're toast. Now that's done. Wind. This is a bit special. Wind sucks away both heat and water from organisms. For some, this is terrible news, but for those that can put up with the wind, they find other uses for it. For example, Plants that live in windy areas can have their pollen spread farther to different areas. And that just means each organism has a range within it can live happily. Rats.
You're geniuses, the lot of you. Oh, by the way, rats are delicious.
I guess I'll have to go for rocks and soil, huh? pH range, pH range.
Well, you don't have to, but we still need to give you lines.
It's fine, I'll just wallow in my lonely corner over here and grow mushrooms in a non-existent closet. Hey look, I got a line. I'm so excited.
I changed my mind. You be quiet now. Okay, now that's over with. So, if we have abiotic factors, that must mean we also have... Dude, why are even the crickets silent now?
You know, Mr. Narrator, you're not too bright yourself.
Shut up! It's all an act. I can't be the only one talking the whole time, can I? So, someone want to try and answer my question?
What question? You never finished your sentence.
You know what I mean.
I know. The biotic factors?
Yes! Our play worked. The narrator is forever gone now.
So now what?
Crap. The show's still going. I guess we ought to finish this.
So I guess we should discuss biotic factors now, huh?
We really don't have a choice. I'll list the factors again then. There's behavior, dispersal, competition, predator-prey relationships. Oh, and don't forget human influence.
I'll go first then. The faster we get this over with, the better. So, behavior. All organisms have their own types of behavior, such as birds. They fly. They also lay eggs. Within the different species of birds, there are also different types of behavior, such as different mating seasons and different sleeping habits. These differences set apart different species of birds.
My turn, huh? Well, dispersal, right. Different organisms disperse in different ways. For example, some plants such as the dandelions in our pole have seeds that are dispersed by wind. Other plants have seeds that catch onto the fur of animals and travel in that way. This type of dispersion is called density-independent dispersion. Density-dependent dispersion is usually displayed by animals and depends on the local population density. If, for example, there are too many deer in one area, so many that they begin dying off, some of the deer might move elsewhere.
Simply riveting.
Oh, come on now. I thought we were done with that wisecrack comments, now that we chased that narrator away.
I just had to try. I'm beginning to understand why the narrator is always so snarky. It's actually pretty fun. You should try to...
Guys, stop. We need to finish this. Okay, so I'm taking competition. Well, when there are organisms that fill similar niches, there's competition between them. Eventually, if one species has an advantage over the other, for example, if it gathers food more efficiently, it may eventually kill off or drive away the other weaker species. This is called competitive exclusion. Competition can also occur within a species, which happens often when the population of a species approaches its carrying capacity. When this happens, some of the population might become more adapted to other types of foods and resources. It evolves to occupy a new niche. This is called niche differentiation. Types of competition include interspecific competition, interspecific competition, interference competition, exploitative competition,
Enough! We've had enough of you for a while.
But I was almost done.
Don't worry about it. I'll take over from here, but we've had enough about competition.
Hey,
So let's move on to predator and prey relationships. Usually when the predator population increases, the prey population decreases. When the prey population decreases to the point where that predators have a hard time finding enough food, the predator population decreases as well. As the predator population decreases, the prey population begins to rise, since there are fewer animals trying to eat them, and so the cycle continues.
and so that concludes our show for today.
Wait, you forgot. We still have to explain human influence.
But I thought that one was obvious.
Yeah, it is. Alright, we're done. Finally, and so that concludes...
You peasants!
Oh, it's you. Why are you back?
I have come to kill you all!
Wait, calm down, please. I beg of you. Wait, don't kill me.
No! You can't tell me I love you! Come back to me!
I'm sorry, but it's time for me to go. Avenge me, please.
I will, my dearest!
My darlings, let me have some of your tasty meat!
No, I refuse. Unhand me, you villain.
Unhand us both and get away from us, you creep. And, my god, did you kill Ash Ketchup? Oh my god. You're a lunatic. Oh my god, my god. Ah!
Wait. Everyone, stop. I just had an epiphany.
What is it?
I just realized we're in a predator and prey relationship. Narrator is the predator, and we're the prey.
My god, you're bloody brilliant. You've managed to tie in this ridiculous scene with the overarching purpose of the show.
You're amazing. Forget Ash Ketchup. You're my new love.
Don't forget me. I'm still here. Well, now then, ladies and gentlemen, wasn't that fun? Now, if you'll excuse me, I need to go home and have my late night tea. Good night.